Okay, so now we're going to learn another way of dividing polynomials, which actually will be much faster in the long run once you understand the hang of it, okay? So it's called synthetic division. Sometimes it's also called, I think, the detached coefficient method. You'll see why in a minute, because we're basically going to detach from the examples. We're going to detach from the variables, the coefficients, and we don't even have to do anything with variables at all. Up here, we had to do a lot with variables. Down here, we're not going to have to use variables at all, which makes it kind of easy. Now, there's something called the remainder method, which we're going to talk about, but we're going to talk about that last, okay? So that's listed here because it's kind of like another shortcut for being able to determine whether a polynomial is a factor or not, okay? But let's go through the steps of synthetic division. So the first thing you're going to have to do is you're basically going to have to find the zero of the factor. So for example, down here, if this is truly a factor of this polynomial, then that means it's a solution. And to find the zero of the x, you have to find out or tell what value does x have to become to turn into 0, okay? So that's what, remember, a solution is also called the zeros of the function. So if this is a 0 of the function, meaning if it's a solution for the function, then we have to be able to determine what x is to make this x minus 3 equals 0, okay? Which that's pretty obvious. That x would have to be a 3, okay? But essentially all you're doing is you're using the opposite sign of the constant term in the divisor. So if this is the divisor, this is the variable term, this is the constant term. Well, the sign in front of it is a -3, so you have to use a +3, okay? You're using the opposite sign of what's in there, okay? So what we're going to do is we're going to write the factor, which is 3, that we're testing over here. We're going to put a little box kind of, or a backwards L box around it, okay? And then what we're going to do is we're going to basically take away the variables. And you can do that in your mind, but you can see them here. And we're going to list just the coefficients that were in front of those variables. We're going to list the coefficients only. We just have to remember using any zeros as placeholders. So we do have to do that placeholder thing every time. So anytime you get ready to do a division problem, make sure that it has all the terms. This one did, okay, because this one had x cubed, and then it had x squared, and then it had x, and then it had the constant term. So it has them all. So I'm just going to list them. 5, I'm going to leave a space, -6, +4, and -1. So I've detached the coefficients from the variables. So this is the hard part, okay? This is the part where people go, what are you having me do? It's a little confusing, okay? I'm going to leave a space because I'm going to write some numbers in here eventually, and I'm going to write a bar, okay? And what I'm going to do is I am going to add down any numbers that I have written underneath of these coefficients. I'm going to put numbers there in a minute. I'll tell you where those come from. But I'm going to essentially start by adding down. The first place that I'm going to do that with is right here with the 5. Well, I haven't written a number yet here under the 5, so there's kind of understood to be a 0 there. But essentially, it just means that I begin the polynomial and begin the division by putting a 5 there. Now, you're going to see this real quickly. We're not dividing anything. That's the great thing about this. There's no division involved. There's adding, and there's going to be multiplying, but there's not going to be dividing, okay? So I'm going to add the numbers down. 5 plus 0 is 5. Okay, so the next step is you're going to multiply up. And this time when you multiply up, remember when we add down, the answer goes under the bar. When we multiply up, and you're going to go, what are we multiplying with? I'll show you in a minute. When we multiply up, we write that answer below the coefficients. So that's what's going to get filled in here. Underneath of these coefficients is a multiplication, okay, an answer to a multiplication. Well, what is it that I'm multiplying? Well, I'm adding down, but then when I multiply, I'm going to take the numbers that I write down here, and I'm going to multiply them with the divisor, okay, the factor of 3. So when I multiply 5 times 3, I get 15, and I'm going to write that up here below the coefficients. Because essentially, if I was doing long division, the first time that I put something up here, this would be where it would go, okay? For example, if I was doing this with long division, you would see really quickly where these numbers are coming from. If I was dividing these with long division, x goes into 5x cubed, 5x squared times. 5x squared times 5x is 5x cubed. Guess what 5x squared times negative 3 is? It's negative 15. Okay, so it gets written there and it's going to cancel. Okay, so you're going to see there's a 6 here. Whoops. You're going to see there's a 6 and a 15. So these numbers kind of relate to what you would see if you were doing this with long division. Okay, it's just a very unusual method. Okay, so now I'm going to add down again. Remember, add down, write it below, multiply back up, add down, multiply back up, add down. So if I add down negative 6 plus 15, that's going to give me 9. Now I'm going to multiply back up. 9 times 3, 27. Then I'm going to add down. 4 plus 27 is 31. Multiply back up. 3 times 31 is 93. Add down. Negative 1 plus 93 is going to give me 92. Now here's the hard part. That's just a bunch of numbers, okay? That's not telling me anything about whether or not this is a factor of this. Well, remember, we detached all these coefficients from the terms. So we got to put them back together, okay? Now, the last term that we find is always the remainder, okay? So this 92 right here, that's the remainder. Okay, so how do I fill in the coefficients? You might be tempted to go, well, wouldn't it just be x cubed, x squared, and x, and then there's no constant because the last term is the remainder? Well, no, because if you think back to what I just showed you a minute ago, if we were really doing this division with the long division method, what you would find is that when we got ready to do this division, we wrote what up here? To get from x to 5x cubed, we didn't write 5x cubed, we wrote 5x squared. We already took out, if this is truly a factor, then we've already took out the x. So it's not going to be still 3x's left in the other factor, because if I multiplied x times 5x cubed, it would be 5x to the 4th. So every answer that you get to any division problem with polynomials, the answer or the quotient always begins with the power that's that's 1 less than what you had in the problem. So if we began with x cubed, the answer is going to begin with x squared. If we began with 5x to the 4th, you would begin with 5x cubed. If it was 5x to the 6th, it would be 5x to the 5th. It's always going to be 1 below where you're at, okay? So that's going to be something you're going to have to just kind of force yourself to remember. So I'm going to write that here in this last step. You're going to write the answer in standard form. But the only thing that you need to remember, and I'm going to underline this, is that you're going to begin with 1 degree less than the original polynomial had. So when I fill back in the variables that I'm going to fill in are not going to begin with x cubed, they're going to begin with x squared. And since this 9 is not a negative 9, I'm going to put a plus. Then I'm going to do the next power below x squared is just x, and then I'm going to put a plus. And then 31 is the constant term. So my answer is really 5x squared plus 9x plus 31, remainder 92. It's actually a much faster method once you understand it, okay? So I didn't ask this, but if it asked whether or not x minus 3 is a factor of this polynomial, you would say no, because there's a remainder. If there's a remainder, then it's not a factor of that polynomial. Okay, I'll do the second example on the next video.